my slides now.
Okay,
Okay.
sir, start.
So yeah. Okay. Thank you one and all for giving me this opportunity to present my research. And today my topic is about intelligent materials and its primitive role in artificial intelligence. First of all, I'd like to introduce myself. Myself, Dr. Loganathan Veeramuthu. I'm working as research assistant professor in National Taipei University of Technology, Taiwan. And first of all, I'd like to introduce where I am situated at present. Okay, so this is the Taiwan map. I used to use laser pointer. Okay, here. This is the map of Taiwan, and this is the capital city called Taipei. And this is the Taipei is one of the famous tourist attraction. It is having nearly 101 floors, 101. And this is my university. This is the main entrance, and we have four entrances, and it is the main entrance. Okay. Now, I'd like to stress why we want to do this kind of artificial intelligence, and yeah, why we want to collect data first of all. Yeah, because in recent years we know that many of us are very focused on data safety and data privacy, and especially, okay, if you want to create the data, how you can create, right? So for example, if you are going to use some wearable electronics, right, okay, you are going to send something, okay. For example, you are going to hospital and they are going to track your records. It's like it's not like a usual way to do, because in usual way we just go to the hospital and they'll record all your clinical records and it will be stored in different way, right? But in terms of wearable electronics, you are going to use some haptic devices. They have some good tactile nature, and most of us don't even know where it is placed, because it's like very transparent and very easily flexible, and it's embedded into our body. There are many type of sensors in recent years, not only just like you can see them visibly. There are many transparent sensors, and something like you can also embed your sensors into your textiles, or even we can transform them into our implantable devices or something like. There are many ways to do it. So all these kind of sensors are going to get your data. Okay, they are going to get some response from your body signals, right? So this is how they collect the data, and these kind of data can be easily connected with the cloud, and then they can utilize for data analytics. And yeah, this is the generalized scheme. Here you can see how they'll connect all these things, how they are interconnected. So what is IoT? Because IoT is nothing but Internet of Things. You are connecting everything with your internet. Okay, for example, your education, hospital, energy system, security, smart cities, agriculture, even aquaculture. They can try to optimize all these things with the help of your single touch internet. Okay, so it's quite interesting. That's why everyone want to transform themselves, and due to the technological evolution, because of 6G technology, and for that, why we need that much data? Because our phone can harvest that, they can utilize that many data, and they are able to grab all the data and they can process and they can send it to the cloud. And yeah, now why we are doing this kind of artificial intelligence? Because we know that they have many advantages in different fields, okay, but there are some few key points that is highly notable. Because in the past, due to the industrial evolution, many people try to transform their research into robotics and something else. Now it's the time for AI, artificial intelligence. And in terms of security and healthcare, and something like detection and wearable electronics, or something like healthcare devices, everything is processed with the help of AI. Because yeah, now I can show you few examples based on wearable electronics, how they can track all the signals and how it works. Okay, these are all the different kind of application we usually see in real time in recent years. And there are many different kind of sensors, and there are many different patterning techniques like microarchitecture, nano architecture devices. And they can also utilize this kind of devices in the therapeutic system, like tissue repair system, or for simulation system like that, or even for wearable photonics. Because everyone know that we are highly dedicated towards preparing some wearable photonics as well, because we know that We are able to do this kind of therapeutics and drug delivery, stimulation, everything. But in order to track everything, you have to carry your mobiles, right? But what you can do further, okay, we can transform our wearable devices as like wearable photonics. Then it's easy to control. You don't want to carry very heavy, like, because most of the heaviness is coming from your battery system. So they also work on this kind of energy storage systems, right? Okay, so now I want to particularly say some material. Okay, there are many intelligent materials. They can respond. They can due to the presence of some light or due to the presence of humidity, water, they can respond with respect to that kind of stimuli. Then you can harvest some different properties. For example, in this case, you can see there are many crystal-like materials. Okay, these kind of crystals, they are called perovskites. Perovskites, they can have some intrinsic crystallinity. Okay, this kind of crystallinic characteristics, they can transform themselves into different kind of interactions, and these interactions can be viable to do many different applications, not only just for normal optic devices. They want something extraordinary, so they can transform themselves from electric transfers, and then they move on to the memory system, and then recently for neuromorphic computing. So there are many ways to do. And especially, I'm working under some nanofiber devices for the past few years. And why we want wearable electronics? Because the recent techniques, most of them, they just focus on some thin film based wearable electronics. But why we want this kind of embedded system or textile based system? Because in this case, you can avoid some discomforts. If you're going to place some thin film onto your body for a long time or patches, you'll have some skin allergy or rashes, something like that, because your skin have to breathe. Okay, so we need this kind of air permeable substrates. And especially if you want to fabricate some sensors, there are many different kind of sensors. I'll introduce you to a little short yeah, I'll introduce you very little short. Okay, here you can see how they can transform. Okay, if you're going to coat some, you just prepare one polymer, you consider that one as your rubber band. Okay, on that you are going to coat some conductive materials, and if you're going to strain them to different percentage, what will happen? The elastic material will come back to its original state, but your coating will get, they are fragile, they are metallic nanoparticles, or yeah, 2D materials. They are going to break apart. Due to that, you lost some interconnection between them. That is called your percolation threshold. So you lose your resistance, or you'll gain your resistance depending upon your stretch or flex conditions. So if our human body have different kind of stress and strain it will experience. Okay, so due to that, your strain sensors or pressure sensors, they can work, they can respond. So this is our recent research we published in ACS Applied Materials. In that we prepared some perovskite based wearable photonics, and then in very recently we also do some self-healable electronics. Okay, what is self-healable electronics? Your skin is getting tampered or it's getting some wound. After some time it will heal on its own. You don't want to give any further stimuli, right? The same way our electronics can also be done. Okay, you don't want to repair, it can repair on its own. So it's quite exciting. We use some polymeric block polymer system, so we can tune all those properties, and then we can achieve this kind of self-healable wearable electronics. So this is quite exciting. And yeah, now I'll introduce you to different kind of fiber forming yeah, methodologies. Okay, there are many different methodology, but my lab is entirely focused on this technique. Why we want electrospinning, I'll show you in a minute. Okay, here this is the setup. We use some polymers, and then we apply some, yeah, electrical voltage there, and then we can control all this kind of polymeric properties, and we can adjust their conditions of preparing methodology. Then you can adjust your, fine tune your micro and nano regimed nanostructures. So you'll end up with different exciting properties. So now I'll introduce you to the light emitters. Okay, here you can see this is called perovskites, and we use some polymers and some N-type small molecules. when we are going to excite them, okay, this is just like you are putting some electrons and holes from one side, and the perovskite molecule, this one is your perovskite, and here they'll try to recombine and then emit the light. So this is
Excuse
how
me,
it
sir.
works in the normal perovskites. Yes.
Sir, slides are not changing, sir.
Oh,
Just
sorry. Ah, before it was moving, now suddenly, or from the beginning itself
so
it's not
from the
moving?
beginning itself, it's not moving, sir. Now it is okay, sir.
Oh my god. Okay, or I'll continue like this. Okay. Yeah,
Sure,
yeah,
sure,
yeah.
sure.
So yeah, we try to develop other techniques like we fabricate many different kind of perovskite based light emitters, and then we are able to control, because perovskites have some good property, like it is having very good optical purity, so it will have very good color emissions. Okay, you can tune them very easily. When you compare to other inorganic molecules, they are highly expensive and it's not easy to process. This kind of molecules are easy to process, and you can solution to preparation. Okay, you can follow the solution way to do it. So you can avoid some energy intensive processes. Okay, the same way, first we are able to do some rigid devices and then we move on to our stretchable and flexible devices, and we end up with some good outputs like this, and we optimize the conditions like this. And here we can also prepare some touch responsive devices. Okay, depending on your pressure, it can light. Okay, so this is how we do the perovskite intelligent materials like that. And then we got to know that perovskites also have another phase. Not only it's going to act as your optical purity, or it's going to be your optoelectronics. Now we can also utilize for getting some energy out of it. Okay, if you put some pressure, piezoelectricity there, what we know is you're going to apply some pressure, then you will end up with your voltage, right? So yeah, this kind of molecular symmetry, they can give you this kind of exciting property. Okay, so in this peak you can see how they characterize. Okay, this is just like phase shift. When you're going to apply some electric field over it, then you can experience this kind of amplitude changes. So if these changes are good, means you can harvest energy very well. And in recent years we know that we are facing a lot of energy crisis in the recent years, and many of us are working on different kind of electronics. Now people have focused on this kind of wearable electronics, especially based on electrospinning technology. And this is our recent review article in which we have discussed everything entirely about electrospinning techniques. If you are interested, please go through. This is an open access journal, so you can easily, yeah, refer these articles. And this is another paper we published recently, and it's focused on some sensory based application based on our electrospun nanofiber structures. And electrospun nanofibers can be used in variety of application, not only for electronics. They can also be used for energy harvesting, batteries, energy storage, and some other biomedical purpose as well. And from this you can see that there are many different kind of sensory mechanisms. Okay, so now I'll introduce you to this kind of piezo-resistive sensors. Yeah, in the previous slide I show you that piezo-resistive sensor. Okay, here the resistance will change depending upon your pressure or strain. Okay, if you're going to strain, or if you're going to give some pressure, okay, you consider this one as your sponge. If you're going
Yes,
to
sir.
apply some pressure, what will happen? The electrical percolation will be created, so the electron can easily flow through. Okay, if it is not having any pressure, then there won't be any electron flow. So the current changes, delta I will be zero in that case. If you're going to apply some pressure, then the changes will happen. So depending on that, by tracking those, you can easily record your blood pressure or something like this. Here you see they are using the same kind of architecture, but this is like they do some wavy or rigid like structures. So here you can see they are able to track their pulse rates here. Okay, the same way they can also do some fiber based
இப்போ
devices
யார் அவங்க
using some
ஃபுல் நேம்
electrospinning
எழுதுறாங்க
like what
அவங்க
we are doing here. And they also developed something like piezo resistive sensors, and this is based on leather based system. Here this is, leathers have two side, one is like corium side and the grain side
வெயிட்
is
நான் இப்படி
highly
பேசிட்டு உங்களுக்கு
porous,
ரிங் வரேன்.
so you can accommodate many conductive particles in it. Okay, so
ம்.
we can establish this kind of networks. When you are going to apply some stress over it, what will happen? You can see the current changes, so depending on that you can track your pressures. Okay, this is how they work. The same way, they can also do some microarchitectures like this by using some
இருங்க நான் இப்போ அவன்கிட்ட
nodes,
பேசிட்டு
and
உங்களுக்கு
then they
சொல்றேன்.
can track different changes. Okay, they can prepare microdome structures, pyramid structures,
இருங்க
and
இருங்க.
pillar structures. So based on COMSOL simulation studies, they are able to
ம்.
track
இந்த
their
ஒரே
stress
நிமிஷம்.
concentration. If the stress
அந்த
concentration is
கேட்கல
high, means
கேட்டுட்டு
you
இப்போ
can
ஃபோன் பண்ணுறேன் ஒரு
experience
டைமில்.
better sensitivity in
ஆமாம்
your
ஆமாம் வேற
devices.
ஆமாம் வேற இது பண்ண சொல்கிறேன்.
Same way,
ஓகே.
in capacitive sensors, you can see how the capacitive sensors work, because capacitance is nothing but this one. Okay, this is entirely depending upon your distance. Okay, you are going to apply some pressure. What will happen? The distance will vary. If you consider, okay, you are going to prepare this kind of spongy structures
சொல்லுவா.
or porous structures, then if you are
நான்
going to apply some pressure to a substrate, what will happen? It will
ஆமாம்
try to
என் வீட்டு
reduce its distance, so you can experience the c changes.
அவருக்கு
Okay,
எடுத்துகிட்டு
the
வந்து தரணும்
capacitance will
எங்களுக்கு.
change. So depending on that, you can track. So
சொல்லுங்க.
this is another study they have done, and this is
ஹலோ
one for showing the difference between flat substrates
ஹலோ
and then 3D substrates. So depending
கிளம்பலையாடா
on
அங்கேருந்து?
the different morphology, we can harvest better sensitivity.
ஹலோ
This one delta c by c naught, here you can see.
கேட்கலடா அங்கேருந்து
And the other
கிளம்பிட்டியா?
one is, okay, these the remaining sensors,
ஏன்டா
what I
எங்கே
have
போயிருக்கீங்க?
discussed in the past, they need some power supply. But now I'm going to discuss
டான்ஸ் ஆட
something
பார்த்துட்டு
like
இருக்காரா?
self-powered sensors. Okay, you don't want to apply any
அப்புறம் என்னத்துல
power to it. You
உட்காந்துருக்கீங்களோ?
don't want to supply
வண்டி
any
வண்டி
energy
எடுத்துட்டு
to
பார்த்துட்டு
work on
இருக்காரு
it.
உனக்கு.
Okay, it will work on its own. Okay, so that is quite exciting. Okay, so now I'll introduce
அப்புறம்
you to
அதான்
those
வருது.
things. And this is another review article we published in which I have discussed about
ம்,
like strain and pressure
ம்,
sensors based on nanofibers and
ம்,
composites. Okay, so please go through if you are interested. And this is another article in which they have
ம்.
shown the importance of resistive sensors by using different kind of wind speeds, because the wind will make the this
நான்
kind
என்ன
of
கேட்குறேன், உனக்கு ஐஐடி
microfibers
சைடு
to
இருந்தால் என்ன நான்
oscillate.
உள்ள வந்து செய்கிறேன்
Depending on
சொல்கிறேன்.
that, the R resistives
நீ
will
பிடிங்கிட்டு இருந்தா
change.
அவ்வளோதான் அப்படின்னு
So
சொல்லிட்டு
you can track the records very easily. So you can
ம்,
monitor the wind
விட்டுரு.
speed during
இல்லைங்க நான்
typhoon or
பண்ணிக்கிறேன் இதை.
hurricane.
நான்
You
என்ன
can track. Okay.
எனக்கு
So
விட்டுரு.
the same way, okay, in the past they
இல்லை
have
என்
done
வீடு
many
இருக்கு, எதிர்க்க
different kind
காலனி.
of
நம்ம என்ன
architectures like
வேணும்
this.
பண்ணட்டும்.
But in
அவன்
my
எவ்வளோ
project, I
குயிக்காக
have
ஓடுறான்,
recently
அதுதான்
done
ப்ரிப்பேர்
this,
ஆகுன்றதான் எனக்கு
and
தெரியல.
this one
ஏன்னா
is called human
எல்லா
skin
பொறுப்பும்
inspired
அவன்கிட்ட தான் விழுது
nanofiber
அப்புறம்.
structures. Okay, now I'll show you how I
அவன்
prepared
செஞ்சான்
this
செய்ய
one.
சொல்ல
Okay, we
சொல்ல அவன்
started
செய்யவே
with the
செய்வேன்னு அவனே
electrospinning
ஒத்துக்கிறான்.
fibers, and then we put some elastomers, some
கபத்தா
polymers. Okay,
வயலாக்குறதுலாம்
you
அதுதான்
just
அதுதான்.
believe it. Okay, I put them,
சரி சரி.
and then
கத்திக்கிட்டு
after
இருக்கு நம்மளை
curing
பொறுத்த
them,
வரைக்கும்
I can
டெக்னாலஜி
peel
இப்போ
them,
லாஸ்ட் செஷன் போயிட்டு
and
இருக்கு.
then in which the
ம்.
nanofibers are
வச்சு
embedded.
செஞ்சுட்டாங்க
Okay, now
செப்பல்
I
செப்பல்
can etch them
ஆரம்பிச்சிருங்க.
because I use some
நீ
water
நீ
soluble polymers.
ஆமாம்
Now
ஹேக்
I can get the patterns
பண்ணுறதும்
like
சில
this. Okay,
கிளம்பாலும்
so you'll have
கொஞ்சம்
many
கஷ்டம்.
nano groups,
கிளி கிளி
and
கிழிச்சிட்டு
then
12
I
பேப்பர்
prepared
தெரிச்சிச்சு.
some
காலையில் ஒருத்தன் 12
nanoparticles,
பேப்பர்
conductive
வச்சான்.
nanoparticles like
12
super
பேப்பர் அசோக்கும்
nanoparticles.
இன்னொருத்தரும்
So how
2
can I affirm
என்ன
that?
கேள்வி
Okay,
கேட்டார்.
these are all
அவன்
schematic. How can you say that
ரெக்கார்டிங்
it's
போட்டிருக்கேன்.
going on?
நம்ம
By looking
எக்ஸ்பர்ட்ஸ் எப்படி
into the
கேட்டிருக்காங்கன்னு
SEM
பாருங்க.
pictures, you can see,
உண்மையான
and
எக்ஸ்பர்ட்
this is
எப்படி
the
கேட்டிருக்காங்க பாருங்க.
AFM. From the
கேட்டால் இப்படி
AFM, we can
ரிசர்ச்சர்
see
தூக்கி
it's
தலைகிறான்னு ஒரு
little
கேள்வியாவது இவனுக்கு
like
கேட்கணுமே
it
பாருங்க
resembles
அப்படின்னு.
similar like our human skin.
ரெக்கார்டே
Okay,
இருக்குது. நீ
so this
கூட
is the
ஆடிட்டு
real time
சொல்லுங்க.
image of our polymeric system being made,
ஆடிட்டு
and
வந்துடுறது
then
பாருங்க.
yeah, we pattern them, and now we can see the comparison between the
நான்
flat
தமிழில் நல்லா
substrates.
படிப்பேன்.
Here you can see they are
ஆர்கிடெக்சர் முடிச்சு
highly
அதுக்கப்புறம் 2
agglomerated,
பேரும் நல்லா
but
வேலை
when we are
பண்ணாங்க.
going to tune their
ஒருத்தர் முடிக்கிறது.
structures by having some nano patterns like this,
வெயிலும்
then you can
இத்தனைக்கும்
see
எல்லாம்
how
ஃபாரஸ்ட்
smooth
ஸ்டூடெண்ட்
it
தான்
is.
அங்கே.
That
ம்
means the surface energy is getting higher in terms of pattern structures,
ம்.
so we can get
நீ
better
நீ என்ன கேள்வி வேணாலும் கேளு.
conductivity. So
கார்த்திகை
you'll have
வந்ததுக்கப்புறமா
very good properties, like
நாளைக்கு
even
அந்த
under
பேர் இருக்கு.
strain. You
நாளைக்கு
see,
இவர்கிட்ட
we
பேர்
do
தமிழ்
some
பேசுகிறேன்னு
stretching
தெரியும்.
studies
இப்படிலாம்
here.
பண்ணான்ட்டு
You can see.
நான் சொல்லிடுவேன்.
Okay,
இது அவ்வளோத்துக்கும் காரணம்
here we
அசோக்
can
தான்டா. நீங்க
compare the
அப்படின்னு
normal
சொல்லிட்டு
structures and pattern
லோடு
structures, and we
முடிஞ்சுங்க.
also do some simulation based study, and we
டீட்டெயிலாக சொல்லணும்னா தான் 1
calculated the
ஹவர் ஆகுது.
mechanical resilience over a period of time. Like, okay, we do many different tensile strength cycles, and we optimize the
யாரு
condition, and we fix which is the
லாரன்ஸா?
best one. Okay,
போட்ட போட்ட சேர்த்து
and
செத்துரும்.
yeah, finally we are able to
மார்க்கர்லாம்
get
ஒரு
some
பிராண்டு
strain
வாங்காம
sensors
எல்லாமே
like
இந்த
this,
சிக்மா
and it
யமா
is
மாதிரியே
quite
இருக்குன்னு
robust,
வாங்கக்கூடாது.
and they have very good recovery
நீ
ratio.
அதுக்கே இப்படி
And
இருக்கியே.
here you can see
நீ
how
2
stretchable it
பேப்பருக்கு
is,
இப்போ
nearly
தான் முடிஞ்சிருக்கு.
200%
பார்த்துக்கோ எவ்வளோ நேரம்.
stretchable, and they are
ம்.
very, they
வச்சு
have,
செஞ்சுட்டாங்க.
they
தரமா
possess
செஞ்சாங்க. ஒருத்தவங்களும்
antibacterial property.
என்ன
Especially
சொல்றது?
we do very
தத்தப்பு
common
தத்தப்புலாம்
bacteria
எல்லாரும்
like
அடிச்சு
E.
அவன் எல்லாம்
coli and
அசிஸ்டன்ட் ப்ரொஃபசர், டாக்டர் தான்.
Staphylococcus
அவனுக்கே அந்த அசிஸ்டன்ட்
aureus.
வச்சிருக்காங்க.
And then
நீங்க
yeah, we
ஸ்காலரை
do
மட்டும் ஹேண்டில் பண்ணிட்டு
some
இந்த பீத்து பீத்துறீங்க.
yeah
ம்.
wearable sensors, and then straining sensitive pressure sensors.
சரி.
Finally, we also extend our work to demonstrate some proof of concept demonstration using some conventional light emitting polymers like this one, PFO, and the other one is ACL device. So we can see how it is working even under flexing condition, and they are quite strong, they are robust. Okay, so the next one is okay, we are able to do all these things by architecturing our surfaces. Okay, now the next stage is okay, I can also show you some self-powered sensors in which we utilize some triboelectricity. Okay, so yeah, we based on the triboelectric effect, we can tune our different polymeric systems and they are stretchable. We use some triblock copolymer system, and then here we can see the mechanism how it works, and we are able to harvest the energy in the form of light, and we can also store the voltages like this, and then we can utilize when we want. And the same way, we also do some piezoelectric sensors based on perovskite material, intelligent materials. Okay, we do with the polymer called PVDF, and PVDF have some different phases. Okay, if you tune the phases to beta crystallinity, then they have higher polarizability. That kind of higher polarization will lead to good self-powered characteristics, so we can harvest the energy. That is how we do. And here, this is the demonstration. You can see we use them in mask, and then even for shoes, under sewing machine and e-gloves. So all these conditions we have done, and it is quite stable even after 60 days. It retained its performances. Okay. So, and very recently we published this one in Nano Energy. And in this case, we are comparing two different kind of fibers. One is reinforced fibers, and the other one is normal fiber. Here you can see how it is reinforced. It is adhered with many small nanoparticles and nanofibers. So they are very highly strong. Okay. So you can compare the differences between normal fiber and reinforced fibers. And here we can see how we do the human machine interfaces. And we are able to predict what they are saying. Okay. So it is quite good to do. And finally, we also demonstrated with the help of, okay, because we are able to do some fiber based devices. But now, if you want to sew them into your normal textiles, if you're going to do, then they lose their functionality because the nanoparticle, if they are not highly othered, it will break and it will tear apart. So you lose your property. So we do all the studies and we do the stability studies in different conditions. Okay, and we optimize the conditions, everything. And now here we can see we are comparing two different structures. One is WSNG. This is normal structure. You see, this is reinforced structures. So from this, we are able to see the voltage generation. It is quite high because if you are going to reinforce them, their beta crystallinity will improve because of the mechanical stimuli we are going to apply when we are going to collect our electrospun structures under reinforcement. Yes, eventually you'll enhance your crystallinity. So that kind of crystalline nature is highly influential in harvesting the energy. And after doing those things, we also demonstrate different uh, real-time applications. Okay, so if you are interested, please go through this article. And finally, yeah, I'd like to conclude that okay, we are able to prepare this kind of wearable sensors and self-powered sensors that is quite good for wearable energy harvesting, as well as we can also use it for diagnostic therapeutics and drug delivery, all these things. Okay, now in terms of Internet of Things, and we have to link them with the different, like okay, for example, you want to link your devices with many different cloud system, or if you're going to interconnect with the other people, what is going to happen? There is some problem like data privacy that is quite important, and especially the data rate and the distance range in which it can work. This kind of things is limiting the Internet of Things. Okay, and artificial intelligence. So people have to think upon those things, and they can work on, yeah, this kind of fields. And these are all the recent publication I have published in recent few years. If you are interested, please go through, and I follow these references for this presentation. And finally, I'd like to thank the organizers, and I welcome everyone to participate in this. Give me the like if you are interested. This is my Google form. You can try to fill this one. Just a minute. I'll put this in the chat. Mhm. Okay. Then here, this is my WhatsApp group. If you are interested in joining my WhatsApp group, that would be fine because, yeah, here I'm giving some guidance for upcoming yearly career researchers. And if they are willing to learn something, resources, everything is provided in this WhatsApp group. And this is my YouTube channel. You can also follow this channel and you can suggest to your friends if they are searching for job or such opportunities. Okay. So yeah, please take a note on it. If you need any further advice on your research or something else, yeah, we can discuss now. Okay, and I'm available in different platforms like ResearchGate, Google Scholar, LinkedIn, Kit. So yeah. And finally, I would like to show the beauty of Taiwan. Here you can see during rainy season how it looks like. And these are all the natural scenic area in Taiwan. And this is during some traditional festivals. I record some. And this is the famous place in the central Taiwan, which is in the high mountain. They have very good tea there, and they have many traditional places to visit. If you visit Taiwan, you can explore all those things. And these are all my team members. I want to thank my professor. He is my professor, Dr. Chichinko, and my teammates. And yeah, if you are interested to join our university, I most welcome everyone. And we have scholarships for international students. Yeah, please visit our website. And I want to thank all my collaborators and funding agencies for supporting me. Okay, thank you one and all for your patience. Okay, I'm open for the questions.
So thank you very much, sir. Uh, Actually, the participants are in live session, so they have to be
Mhm.
texted in the chat box. Then only we can ask questions. Uh,
Okay,
so we will text the questions to you, sir. Actually, your presentation was very
okay,
nice, and it was very energetic, and also new ideas are created through this